There is a building in Ukraine that looks like it was made yesterday. It is enormous. A smooth silver arch, 108 meters tall, 257 meters across, sitting in a landscape where nothing else has been touched since the 1980s. And it was deliberately built in the wrong place. Not wrong as in badly planned. Wrong as in they built it 300 meters away from where it needed to go, finished it there, and then pushed it. Which raises the only question that matters here. Why would you build the largest movable structure in human history somewhere it does not belong? Because the impressive part of this project is the part you can see. The span, the scale, the clean silver skin. None of that was the hard part. The hard part is a constraint that shapes every single decision in this build, and it is this. Radiation dose is cumulative. Time spent near the reactor is not free. Every hour a worker stands there is an hour they can never spend there again. So the entire project is organized around one idea. Keep people away from the work. To understand how strange that is, go back to what is underneath the arch. In April of 1986, reactor number 4 exploded. The roof came off. The core was open to the sky, and the material that had been inside the reactor was now outside it, scattered across the roof of the building next door. Somebody had to pick it up. This is exactly the job you send a machine to do. Dangerous, repetitive, lethal. That is what machines are for. So they sent machines, remote-controlled vehicles, engineering robots, even machines derived from lunar rover designs built for places humans cannot go. Every one of them failed. Not mechanically. The radiation on that roof was intense enough to destroy the electronics inside them. Ionizing radiation strips charge through semiconductors. Logic gates flip. Control circuits scramble. The machines wandered off, stopped answering, and died. Understand what that means. The environment was too hostile for robots, so they used people instead. Soldiers went onto the roof in shifts with a shovel and a time limit. 90 seconds. Run out, scoop a few kilograms of debris over the edge, run back. They were called biorobots. That was the actual term. Machines had failed, so human beings were used as replacement machines. Over that summer, more than 3,800 men went up there, 90 seconds at a time. Then, around the ruined reactor, they built a shelter. 206 days, concrete and steel, assembled by people who could only stay for minutes. It worked. It was also never meant to last. Some of it was welded remotely. Some of it was lowered into position and left. Nobody could stand there long enough to survey it properly, which means nobody fully knew how strong it was. And it was getting weaker. Rain got in. Steel corroded. The structure began to sag in places that could not be inspected because inspecting them meant standing next to an open reactor. So there was a deadline nobody could see. At some point, that shelter was going to come down, and if it fell onto what was underneath, it would throw radioactive dust back into the air. Which gives you the real problem. How do you build something over a reactor when standing near that reactor is the exact thing you are trying to avoid? Normal construction assumes you can be there. Surveyors walk the site. Crews work above the structure. Welders climb the frame. Inspectors check the joints. None of that is possible here. Almost none of it anyway, because one part of this job could not be moved anywhere. The arch had to stand on something. So before any of it existed, crews went to the reactor site and put in foundations. 400 piles, a meter across, driven 19 meters into the ground, carrying 2 long concrete beams for the arch to sit on. That was the one piece of work that had to happen next to the reactor, and it was measured in doses rather than in days. Everything above those beams was built somewhere else. They cleared ground about 300 meters away, far enough that the dose rate allowed a normal working day, and built the arch on that spot instead. And the shape is doing more work than it appears to. An arch carries its load in compression, pushed down its own curve and out into the ground at each end. Which means it needs no columns in the middle. No columns matters enormously here because a column has to stand on the floor, and the floor is the reactor. An arch lets you roof 257 meters while touching the ground only at the 2 edges, both of them on clean prepared beams. It also leaves the entire interior open, which is exactly what the cranes need. And it gave them 2 rails to slide along, because the span is not sized to cover a reactor. It is sized to swallow the old shelter whole. They were not roofing a ruin. They were roofing another building without touching it. The engineering gets cleverer still, because even on the safe side, they kept people low. Each half of the arch was assembled lying near the ground, then lifted in 3 stages. Raise it, add the next section underneath, raise it again. Crews worked at low level almost the whole time instead of climbing 100 meters of steel. The lifting was done by 56 strand jacks, controlled together by software, because 56 jacks lifting one object have to move as one. If one corner rises faster than another, the frame twists and the joints tear. They built the first half, raised it, slid it aside, built the second half in the same space, slid the first one back, and joined them. Then they had to move the whole thing, not lift it. Nothing lifts 36,000 tons. Slide it on rails 327 meters until it sat over the reactor. The pushing was done by 224 hydraulic jacks driving a skidding system, riding on skid shoes rated at 700 tons each, advancing the entire structure about 60 centimeters per stroke. Push, reset, push again. And here is the difficulty that is easy to miss. The 2 rails were 260 meters apart. A rigid steel arch riding on 2 tracks that far apart will destroy itself if one side gets ahead of the other. So the whole move was continuously monitored and synchronized, both sides advancing together, 60 centimeters at a time. It took roughly 2 weeks, in November of 2016, to walk it into position. That is the trick the whole project rests on, not the shape of the arch. The decision to build it somewhere else and bring it to the problem. But sliding it into place only solves the first century of the first problem. Because now you have a steel building that has to survive 100 years over an open reactor. So what actually kills a steel structure over 100 years? Not load, not wind, rust. And you cannot send painters inside to maintain steel that is sitting above the most contaminated room on Earth. So they solved corrosion by removing what corrosion needs. The arch is not one shell, it is 2. An outer skin and an inner skin, with a gap between them that reaches about 12 meters in places. That whole cavity is dehumidified and held below 40% relative humidity. Below that threshold, the thin film of moisture that steel needs to corrode does not form. No electrolyte, no reaction, no rust. The 100-year life of that building is, in the end, a dehumidifier. Then there is the air itself. The cavity between the shells is held at a slight positive pressure, around 50 pascals. The contaminated space inside is held slightly negative, which means every leak in that building leaks the right way. Air pushes inward, toward the reactor, never outward toward you. The building breathes in, and inside it, mounted to the roof, are cranes designed to be operated remotely, because covering the reactor was never the goal. The goal is to take the old shelter apart, and eventually the reactor with it, from inside a sealed building, by remote control over decades, without anyone standing in the room. The arch is not a lid. It is a workshop wrapped around a problem too dangerous to approach. It was designed to last 100 years, which means the people who built it accepted they would never see it finish its job. They built for a century. They got just under 9 years. On the 14th of February, 2025, a drone struck the roof. It started a fire inside the double shell, in the one place nobody could easily reach, and it burned for about 3 weeks before it was confirmed out. Roughly half the northern roof was damaged. Cladding was destroyed across hundreds of square meters. The inner containment was not breached, and radiation levels around the site stayed normal. But the assessment afterwards was blunt. The structure had lost its primary safety function. As a confinement system, the arch no longer does the one thing it was built to do. The largest movable object ever built, 100-year design life, defeated in under a decade by something that was never in the specification. And that is the part worth sitting with. Every engineering problem in this story was solved. Radiation was solved by building somewhere else. Weight was solved by sliding instead of lifting. Height was solved by lifting in stages. Access was solved by remote cranes. Corrosion was solved by taking the humidity out of the air. The thing that broke it was not an engineering problem at all. So when you look at that silver arch again, you are looking at several things at once. You are looking at a building put together in the wrong place on purpose, because the right place would have harmed the people building it. You are looking at 36,000 tons advanced 60 centimeters at a time, on two rails that had to stay in perfect step. You are looking at a 100-year design life that comes down to keeping the air dry, and a safety system that works by making the building leak inwards. You are looking at 3,800 men with shovels, 90 seconds each, who made all of it possible before any of it was designed. And you are looking at a 100-year structure that lasted 9. There is a building in Ukraine that looks like it was made yesterday. It was built to outlive everyone who built it, and it did not.